Okay. Up to this, we have studied how torque is produced when current passes through a coil, rectangular coil, when it is placed in a magnetic field. Uh, this is the conversion of electrical energy into mechanical energy, which is utilized to construct not only galvanometer, moving coil galvanometer, but this principle is applied to construct electric motor. So what is the function of electric motor? Electric motor is just, it is rotated. When current passes through, it rotates. When one system is applied, one axis is fixed with the coil, when current is allowed to pass through it, and in case of motor only just one ring system, that is a sliding ring is fixed here in such a way that this slides and one brass system is connected so that current can be continuously passed through this coil. Okay, so when coil rotates, this will change the direction. Okay, this cylindrical system and brass will always allow the current to pass through it, and it will pass through the coil. When current passes through the coil, it experiences a torque and it starts rotating, right? So at this end, the axis is rotated and axis is fixed with the coil. Then when axis rotates, then it performs the action of a electric motor, right? So this is what we have observed from current. When current passes through a coil, when coil is placed within a magnetic field, okay, the effect on the coil. So now in earlier topics, when current passes through a conductor, it produces magnetic field, right? So applying Biot-Savart law, we can find out the value of magnetic field around the conductor. That is, when current passes through a conductor, it produces a magnetic field. That is, current when passes through a current passes through a conductor, it produces magnetic field. But the reverse action, it was first started by Oersted, right? Next, from magnetic field, whether current can be obtained. Okay. Initially, we observed that current produces magnetic field, right? Current or magnetic field pabo paro. Okay. Magnetic field or current pabo parimne. This type of experiment was done by two well-known scientists in 1800. Initially, 1831, Michael Faraday. From England, right? Michael Faraday, one scientist from England, and simultaneously from USA, another scientist, Joseph Henry, from USA, about 1831. So both of them started a number of experiments. Faraday perform series of experiments to show that magnetic field can also produce electric current. That current is called induced current, right? That current is called induced current. So, so far we have studied that when current passes through a conductor, it produces magnetic field. So, alternate effect started started experiment start from 1831. The first experiment was performed by Michael Faraday from England. Simultaneously, at the same time, from USA, Joseph Henry also started an experiment on this topic. That is conversion of magnetic field into current. That production of current is called induction. That is the induced current or induced EMF, right? So very interesting topic. So we are going to start electromagnetic induction. What does induction means? Induction means that there is no direct touching. Without touching, the effect produced is termed as induction, right? So in this chapter, we'll be going to start electromagnetic induction. First, we will study Faraday's two important experiments. Okay. Out of series of experiments, বহুত experiment কৰিছিলে তাৰ ভিতৰত we'll discuss only two experiments. Faraday's experiment 1, first experiment. This is very simple experiment, right? This very simple experiment. A coil, okay, a coil is connected with a galvanometer, right? This is a galvanometer. Nothing. A simple coil. There is no battery, right? There is no battery, only galvanometer. Why galvanometer is connected? When current passes through the coil, galvanometer will give deflection, right? So, in the experiment, one bar magnet is taken. South pole. The bar magnet is placed in such a way that it can be moved forward and it can be moved backward. Okay. Okay. So a bar magnet is placed in such a way that it can be moved forward and it can be moved backward. Right. A system is done with a bar magnet. So this is a simple arrangement of his first experiment. So according to the experiment, if the magnet is moved forward and backward, then the galvanometer will show deflection in both directions. Right? Very simple experiment. যদিহে ম্যাগনেটডাল আগলৈ পিছলৈ অনানিয়া কৰি থকা হয় তেতিয়া হলে ইয়াত ইনডিউসড কারেন্ট প্রডিউস হবে সো ইনডিউসড কারেন্টৰ কাৰণে আগলৈ নিলে যেটো ডিৰেকচনত গ্যালভানোমিটাৰ কাটাডাল মাৰিব তো 0 10 20 10 20 কাটাডাল যদি হিফালে মাৰে আগলৈ নিউতে এফালে আনিলে এফালে। So experiment is very simple, but minute observation is required. The deflection may be very small, right? Still there is a deflection. If you move fast, then deflection will be more countable. Deflection to aro bhalo hobo jodi tumi khub fast onaniya kora. Why? Next question is why? Why current produces? You see, without touching, without battery, current produces. This is very important. Without touching, without any supply battery source, no battery is connected. So galvanometer shows deflection. This is very meaningful. Why? Kyo hoy? Tar karone ami jabo lagibo magnetic lines of force. So magnetic lines of force, if we draw, we do not see our naked eyes. Ami khali sokure dekha napao. So magnetic lines of forces are passing through the coil, all the coils. So as we have discussed about magnetic flux, what is flux? Flux is the magnetic lines of force passing through inlet area, right? So magnetic flux, lines of force, these are the areas. Okay, the lines of force of this magnet, when we move up and down, when there is a relative velocity between coil and magnet, then magnetic flux changes. This change of magnetic flux induces a current. মানে যেতিয়াই ম্যাগনেটিক ফ্লাক্স এই ফ্লাক্সটো চেঞ্জ হ'ব তুমি যদি উচৰলৈ নিয়া ডেন্সিটি বাঢ়িব আঁতৰাই নিয়া ডেন্সিটি কমিব ইয়াৰ মিনিংটো হ'ল whenever magnetic flux associated with coil changes হলনি ঘটে তেতিয়াই EMF is induced EMF হলেহে কারেন্ট হ'ব and EMF is induced in the coil. That EMF is called induced EMF. And the current concerned is called induced current. So from this experiment, conclusion is drawn in the form of a statement. The statement is called first law, Faraday's first law. Faraday's first law, very important. Whenever you will get any textbook, whenever magnetic flux associated with a coil changes induced EMF is set up in the coil. The current so produced is called induced current, right? So very simple statement. Whenever magnetic flux associated with a coil changes, induced EMF is set up in the coil. The current so produced is called induced current. So তুমি আগলৈ যদি নিউটে যিটো ডিৰেকশনত কারেন্ট হ'ব আনোতে উল্টা আনোতে আতৰাই নিউটে তাৰ উল্টা ডিৰেকশনত কারেন্ট হ'ব okay that is why the pointer in the galvanometer will deflect in both the directions. Question to হ'ল যদি তুমি ৰখাই থোৱা if both are stationary there will be no deflection. So note it যেতিয়া দুইটা ৰৈ থাকিব কোনো ধৰণৰ ফোর্স ইয়াত তুমি নাপাবা you will not get any force any deflection মানে relative motion থাকিব লাগিব whenever there is a relative motion between coil and the magnet coil and the bar magnet relative motion থাকিব লাগিব তুমি Next question. ইয়াত যদি ৰখাই থোৱা ইয়াত অনানিয়া কৰা তেতিয়া হ'ব না তেতিয়াও হ'ব if you fix this magnet stationary and allow this coil to move forward and backward, then also you will get deflection, right? In both cases you'll find deflection, right? So this is the important first law. You see, very interesting, right? Without any battery, without any source, it produces it produces EMF. That is, we know that when galvanometer gives deflection, there must be current. Galvanometer te ki kore hepaledi current gole mane e deflection dekhabo. So galvanometer deflection dekhwa mane hol that current ase. So current pabolo hole amak battery lagibo, yet battery nai, there is no battery. So this is important. So Faraday done it 1800 century. Next experiment, experiment 2. Let us see. In the second experiment, Faraday observed that here for second experiment 2, he used two coils. Suppose this is a soft iron core, and insulated coil is connected. Okay, insulated coil is connected. In the second experiment, this is soft iron core, and one coil is connected. This is galvanometer, and another coil which is also insulated. Okay, positive, negative, right? You see, this soft iron core, in the second experiment, one soft iron core, core means moja, and insulated wire, maybe copper wire. Eta soft iron core কাম কি মানে আয়রনে হয় সফট হ'ব লাগিব সফট হার্ড দুবিধ আয়রন থাকে ইয়াৰ কাম হল ই ম্যাগনেটিক লাইনস অফ ফোর্স বিলাকক কনসেন্ট্রেট কৰি দিয়া ঠিক আছে সফট আয়রন কোর থাকিলে তাৰ মাজেদি লাইনস অফ ফোর্সৰ ডেন্সিটিটো বেছি হয় বেছিকে ম্যাগনেটিক লাইনস অফ ফোর্স সোমাই যায় ইনসুলেটেড ওয়্যার মানে ওয়্যার বিলাকৰ ইনসুলেট কৰি থোৱা আছে বুজিলে Insulate কৰা meaning to holi iron to লগত টাচ কৰি থকা নাই iron লগত টাচ কৰি থকা নাই টাচ কৰি থাকিলে তো so you see in the second experiment what happens when current is allowed to pass through this coil as soon as current passes through the coil the magnetic lines of force associated with this coil increases from 0 to infinity. So as you know, when current passes through a coil, it behaves like a magnetic solenoid. That is, it behaves like a magnet, right? As we have discussed that solenoid. It is a solenoid, just like a solenoid. When current passes through it, as soon as current passes through it, it means that it produces magnetic lines of forces. It produces magnetic lines of forces from 0 to infinity. It means that you are bringing a magnet from infinity to 0 to infinity, right? So coil, you are changing the position of the magnet. Here manually you are changing the position of the magnet. Okay, when you manually change, the lines of force changes. Okay, passing through the coil changes. So here, as soon as you switch on, current passes through. When current passes through, it means that initially there was no magnetic lines. When current passes through it, the magnetic lines of force starts from 0 to infinity, just like this. The case is similar to bringing a magnet from infinity to near of this coil. Okay, so in this coil, the secondary coil, this coil is called primary coil, this coil is called secondary coil. In the secondary coil, there will be EMF induced. Induced EMF will be produced. So galvanometer will give deflection. As soon as you switch off koriba jetia loge loge akoi opposite direction of dekhabo. Tar meaning to hold, when switch is off, the magnetic lines of force decreases from infinity to 0. Right? Yak atrai niya nisna hobo. So magnetal jetia tumi usorole niba, jetia 0 to infinity, jetia atrai niba, backward movement. So infinity to 0. Lines of force bilak infinity pra 0 le komi jabo. So in that case, galvanometer will deflect, right? When you switch on for a long time, jeta tumi bahut samoyar kana switch on kori thoba, there will be no deflection, right? Etia etu hol second experiment tur pora ei kotha khinike এই কথাখিনিকে যে ফার্স্ট এক্সপেরিমেন্ট করেছিল অনানিয়া করেছিল সেটা ম্যানুয়ালি নকৰিলেও হ'ব ইয়াত যদি alternate current এটা দি থোৱা হয় if alternate current is given here alternate source এটা যদি দিয়া হয় next we'll discuss what is alternate source if alternate source or oscillator is connected when both direction changes right positive and negative then no need to move this bar magnet upward down forward and backward because if you connect an alternating source here what will happen it will change the direction of current in this coil at any moment with a fixed duration at the same time induced EMF will be produced continuously so you will find induced EMF here okay so here also you will get induced EMF at this point. So this principle is used in transformer, right? In transformer, this principle is used. So second law, Faraday's second law is important. It gives the magnitude of induced EMF. The second law gives the magnitude of induced EMF, right? What is the statement? The statement is that the rate of change of magnetic flux. The magnetic flux is represented by phi. The rate of change of magnetic flux gives the magnitude of induced EMF. It is induced EMF epsilon is equal to del phi by del t. Okay. If n is the number of turns in a coil and del phi by del t. Okay. So this expression gives the value of induced EMF epsilon. So this law is very important. So along with this law, using Lenz's law, uh, you'll be able to find out the direction. Okay, direction of North Pole. What is Lenz's law? So another important point is that Lenz's law. What is Lenz's law? So suppose there is a coil. There is a coil. Okay, there is a coil. You are connecting a galvanometer in the coil. So you are bringing a North Pole towards the coil. Okay, you are bringing North Pole towards the coil, right? Lenz is a scientist. From the point of conservation of energy, he has done an experiment and concluded that when the North Pole is brought towards the coil, immediately the current will be such that it will produce a North Pole in front of the coil. যদি এনেকা থাকে এটো যদি কয়েল হয় এটা কয়েলৰ ফ্ৰন্টত এটা নৰ্থ পোল মই দিছো মেগনেটডাল এটা নৰ্থ পোল এফালে পৰিছো এফালে নৰ্থ পোল এফালে সাউথ পোল পৰি যাব সো নৰ্থ পোলক কি কৰে ৰিপিল কৰে
Thank you, sir.
Okay.
Yes, sir.